See this question. In this question, this circuit is given and we have to find the current in this 2 ohm resistance. Here, it is important to know that one source is DC voltage 10 volt and another source is 5 cos t, that is 5 cos 2t. Okay, so these are two different sources. One is constant DC and another is cosine voltage source that is alternating. Okay, so such circuits can be easily solved by using superposition theorem. Here, suppose first this 10 volt DC is applied in circuit. So when 10 volt DC is applied, then this inductor will act as short circuit for DC and this capacitor will act as open circuit for this DC. Okay, so capacitor act as open circuit and short circuit this sinusoidal voltage source. In that case, we get I1 that is equals to V by R, that is equals to 10 by 2 and equals to 5 ampere. Now, if this 5 cos 2t, that is alternating voltage source, is applied in this circuit, then in that case we can draw circuit as, see, when this is applied, in that case this 10 volt we act as short circuit. So we will short this voltage source. Now what is inductance? What is inductive reactance? That is equals to omega L. Omega is equals to 2. So we can write it as J2. This is 2 ohm. And what is capacitance? See, capacitance is equals to, capacitive reactance is equals to 1 upon j omega c. Here 1 by j omega is 2 and c is equals to 1, so 1 by j2. Okay, and this is 5 cos 2t. Okay, so we can write it as 5 angle 0. So now apply simply nodal analysis. Suppose voltage at this point is V, so we can write V by J2. Treat this node as reference node. V by J2 plus V by 2 plus V minus 5 angle 0 by 1 by J2 is equals to 0. So on solving this we get minus 3V plus JV is equals to minus 20 angle 0. Okay, so from this we can find V as minus 20 by 3 minus J, and this 3 minus J can be represented as, what is the magnitude of 3 minus J? That is equals to root 3 square plus 1 square. And what is the angle? Angle is equals to tan inverse B by, that is minus 1 by 3. Okay, so we can write V is equals to minus 20 by under root 10 angle 18.43. Okay, because when this negative angle goes in numerator it will become positive, so that is equals to, sorry, this is, so it is equals to 2 root 10 angle 18.43. Okay, now what is current I2? I2 is simply given by 2 root 10 18.43, that is voltage, upon this resistance, that is 2 ohm. So we get simply root 10 angle 18.43. So this is current I2. Okay, now what is total current I? when these both sources are applied simultaneously, then current I is I1 plus I2, that is equals to 5 plus root 10 angle 18.43. Okay, it means cos 2t minus 18.43. So this is the answer. Now see this question that has been asked in ES 2000 and ES 2003. Here in this circuit, power consumed by resistance R when one source is acting at a time, and power is measured 18 watt, 50 watt and 98 watt. It means when only E1 act on this resistance, then power measured is 18 watt. When E2 acts, then power measured at this resistance is 50 watt, and when E3 act alone, then power measured through this resistance R is 98 watt. Okay, and this network is resistive network. It means it is a linear network. So how we can solve this question? So here, as we know that this network is linear, so we can easily apply the superposition theorem. Suppose when E1 act, in that case power P measured at this resistance R is P1, that is equals to 18 watt, and that is equals to I1 square R. So from this we can write I1 is equals to root P1 by R. Now when E2 act, then we can write similar equation that I2 is equals to under root of P2 by R. And when E3 act alone, then in that case I3 is equals to under root of P3 by R. Now when all these three sources act simultaneously, in that case what is the current? That current will be equals to sum of all these three currents, that is by superposition theorem. But here there is a twist. We don't know the direction of current, so we take both plus minus sign because direction of current is unpredictable. So we can write total current I is equals to plus minus I1 plus minus I2 plus minus I3. So what is I1, I2 and I3? Put the values of I1, I2 and I3. So we can write plus minus root P1 by R, okay, plus minus root P2 by R plus minus root P3 by R. If we take R common, then we can write the equation as 1 upon R plus minus root P1 plus minus root P2 plus minus root P3, where P1, P2 and P3 are 18, 50 and 98 watt. Now what is total power PT? We have to find the maximum and minimum values of power in R. So what is total power? That is equals to total current I square into R. Okay, this is resistance R, so total power is I square into R. And what is I square? That is equals to plus minus root, what is P1? That is 18 plus minus under root of 50 plus minus under root of 98 whole square of this. This is total current I square into R. And here we write 1 upon R square. Okay, so this is the value of total resistance, total power PT. Now what is maximum power? See, here this r will cancel out. Okay, this r and r will cancel out, so we will get only this, because this is root r. Okay, so when we square this we get r, and this is r, so and r will cancel out. So total power P is simply equals to root 18 plus minus root 50 plus minus root 98. So here from this we can take under root 2 common. Okay, take root 2 common, then there is remain 9, so we can write plus minus 3, and if we take root 2 from this common, then root 25 will remain, and so we can write root 25 as plus minus 5, and from 98 if we take root 2 common, then 49 will remain, and square root of 49 is 7, so plus minus 7 and whole square of this. So total power Pt is equals to 2 into plus minus 3 plus minus 5 plus minus 7 whole square. Now when this power is maximum, see, this power is maximum when all these three currents are in same direction, that is I1, I2 and I3. Either all of these currents are in positive direction or all of these currents are in negative direction. In this case we get the maximum power. So when all these three terms add on, in that case we get maximum power. So what is maximum power? That is equals to 2 into, add all these three, 7 plus 3 10 plus 5 15, that is 15 square, so that is equals to 450 watt. Now what is minimum power? Minimum power is equals to, see, when this power is minimum, when we add this 5 plus 3 and subtract 7 from it. Okay, in that case we will get minimum terms, that is 1. So minimum power is 2 into 5 plus 3 minus 7, that is equals to 2 into 1 square, that is 2 watt. So maximum power through this resistance R is 450 watt and minimum power is 2 watt.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.